All right, good evening. I'd like to welcome everyone tonight to a webcast by My Horse University and Extension's Horse Quest. The title of our presentation tonight is Countermeasure for Equine Laminitis, Carbohydrate Profiles in Feeds and Forages. Today's webcast is sponsored by Heartland Veterinary Supply. Heartland Vet Supply has been in business since 1981 as a functioning veterinary clinic involved with the diagnosis and treatment of health problems in the equine, canine, and feline species. They are America's horse, dog, and cat discount supply headquarters and award-winning discount cataloger. For more information, visit their website at www.heartlandvetsupply.com. The presenter today is Dr. Bridgett McIntosh from the University of Tennessee, where she is the Extension Horse Specialist. Her main role is to develop and implement adult and youth equine educational programs throughout Tennessee. In 1997, she earned her bachelor's degree in biology from Hollins College, where she was a member of the IHSA team and also showed hunter jumpers in local and A-rated shows. In 2003, she graduated with her master's degree in animal science with a concentration in equine from Virginia Polytechnic Institute and State University. There she studied feed intake and digestibility in horses. Finally, Dr. McIntosh earned her PhD in animal science, also with a concentration in equine from Virginia Polytechnic Institute. Bridgett was also awarded the John Lee Pratt Fellowship in Animal Nutrition to study carbohydrate profiles in feeds and forages in the avoidance of equine laminitis. Please note that you are able to ask questions during the presentation via the text chat at the bottom of your screen. The questions will be answered by Dr. Tanya Cubitt. Tanya is a native of Queensland, Australia. She completed her Master of Science and Doctor of Philosophy degrees in Equine Nutrition and Reproduction at Virginia Tech. Dr. Cubitt has a wealth of knowledge in nutrition as it relates to reproduction and has a background that includes all aspects of equine farm management. There will also be time at the end of the presentation for additional questions that you might have. Our presentation tonight will be recorded and we will upload it to our website by the end of the week if you would like to review the talk at a later date. And so without any further ado, I'd like to turn the presentation over to Dr. McIntosh.
Thank you, Gwen. Can everybody hear me okay? If a couple people could just write in the chat. Tanya, maybe? Okay, great. Thanks, guys. Well, this is really neat. I'm feeling very virtual and techie all of a sudden as I sit here and realize that this is a fun way to give a talk because I'm in my barn clothes and I have my little Jack Russell sleeping in the chair behind me because he wanted no part of being locked out of the room. So I hope he doesn't start whining partway through. Okay. So to get us going, I thought it would be nice to provide a bit of an outline. The first thing we're going to talk about is what laminitis actually is and look at the different aspects of hoof anatomy, both in a normal horse and then a horse that's afflicted with laminitis. We're going to focus on the dietary causes of laminitis. There are a multitude of different causes, but for this talk, we'll be focusing particularly on pasture-associated laminitis. We're going to talk about risk factors for the disease in horses, and what a risk factor is, it's just a condition that increases the likelihood of the disease. So we're going to talk about different things that may make your horse more prone to laminitis than another horse. Oops. Then we're going to talk about risk factors or different things associated with forages and feeds that may increase your horse coming down with laminitis. And we're going to talk about some of the research I did, particularly with risk factors in pastures, and then talk about ways to avoid laminitis, particularly those horses that are out on pasture. In defining laminitis, people often think that a horse has to be lame or have an obal degree of lameness in order to have laminitis, but it's actually a systemic disease that a horse can have before any lameness shows up. It then, however, manifests itself in the horse's hoof, resulting much like you see in the picture on the right here. In general, it's inflammation and degeneration of the soft tissue, which is called the lamina, which connects the hoof wall to the coffin bone. And the coffin bone can also be called the pedal bone or the P3 bone within the hoof. So then what is founder? Because oftentimes we see these two words used synonymously. Founder is actually when you get rotation of the coffin bone or pedal bone within the hoof due to laminitis. So there's actually a change in the anatomical structure within the foot. Chronic laminitis is the rotation of the coffin bone within the foot, and that's much like you see here in the picture on the right, and we'll go through some other photos as well. But you can see that it's misaligned and that coffin bone rotates so that the toe part of it points downward. The horse then becomes lame due to pain associated with that change. So this is the anatomy of a normal horse hoof. So you see your hoof wall on the outside, and then the laminar junction, which connects the coffin bone to the hoof wall. So the laminar junction is made up of all the lamina. There's also a deep flexor tendon which goes all the way along the bottom, which you can't see real great here. This is hard to do without a pointer. But there's a deep flexor tendon which pulls that coffin bone down as that laminar junction degenerates with laminitis. This is a cross-section of the inside of an equine hoof. I just like this picture because it shows you all of the lamina, which are represented by the letter L, which are these finger-like projections that form a bond with the hoof wall and coffin bone. At the top, the C is for the coronary band. So in looking at some more microscopic type pictures of lamina, there's both epidermal and dermal lamina. So dermal lamina are these finger-like projections that come out from the hoof wall towards the coffin bone, and epidermal lamina come out from the coffin bone and attach to the dermal lamina, making that very, very strong connection. There's also primary and secondary lamina. So this, on the picture on the right, the larger white longitudinal projections are the primary, and then they have millions of little tiny fingers that come off of them so that these guys can really intertwine and connect together very much like a Velcro. And the basement membrane on the bottom picture, that's just the area that's in between these laminar junctions, and that's where nutrients like glucose are exchanged between the tissues, because just like any other tissue, they need glucose in order to survive. That's their main nutrient. So what happens when that laminar junction becomes degenerated and separates is that the coffin bone then becomes unattached to the hoof wall and rotates downward. And you can see in the top picture that the greatest area of rotation is down towards the toe, so that in the bottom picture you can see that bottom portion of the coffin bone is actually pressing into the sole of the hoof. And you can imagine that if you're a 1,000 or 1,200 pound horse and all of your weight is being pressed from this coffin bone into the sole of your foot, it's a very, very painful and disabling disease. The separation between the hoof and the bone, again, is greatest at the toe. Okay, so what are the causes of laminitis? Well, there's many different causes, but you can see the area in the green comprises almost 50% of the causes of laminitis, which is lush pasture. Another 7.5% is from grain overload. So those two causes combined make up almost 50% being dietary causes. And then there are colic and diarrhea and retained placenta with endotoxin release can also cause laminitis, but we won't be talking about that kind tonight. Can everybody hear me okay still, or do I need to check anything? Tanya or Gwen? Okay, super, thanks. It's hard to get distracted by reading the text chat. Thank you. All right, so before we can really get into the nuts and bolts of the nutritional causes of laminitis, I think we need to start with the basics of equine nutrition, because oftentimes it's really misunderstood by many horse owners, and including myself until I began studying this area. So horses are non-ruminant herbivores. Non-ruminant meaning that they have a simple, non-compartmentalized stomach, and herbivore meaning that their primary component of their diet should be forage or long-stem roughage. And that's because the digestive system is designed to utilize that fiber or roughage from the forage via millions of bacteria in the hind gut that break down that forage through the fermentation process. And then that releases what's called volatile fatty acids, which the horse in turn uses for energy. Feeding behavior is also often misunderstood. Horses were designed to eat small, frequent meals. And oftentimes, as you all know, we take horses and we put them in stalls and restrict their diet to 2 or maybe 3 times a day, or maybe we don't have adequate pasture, so they're out on dry lot, and we're really compromising their natural grazing behavior. In the study that I did, which we'll talk about in a little bit, we had horses that were out on pasture for 24 hours a day, and we monitored their behavior, and we found that they grazed anywhere from 14 to 18 hours per day, and that really depended on the climate and the temperature and different environmental factors. They also covered distances up to 20 kilometers or about 10 miles per day, and we had 10 horses in about a 10-acre research field. So even within that small area, they're really moving around the entire time and taking little bits in at once, which helps keep that digestive process going. The real point here is that their ability to digest a large amount of feed or forage at once is quite limited. They don't have the capacity to digest a large amount at once. Okay, so this is a neat figure here that kind of shows what a horse normally would do if they're not laminitic or just on a regular pasture. So a horse would take in small, and the little green dots represent small boluses of forage, little meals throughout the day. And they hit the stomach, which is the little yellow guy down at the bottom, and the passage rate through the stomach is pretty rapid. And then the digestive hits the small intestine, which is the snake-like structure, and you'll get at the top, you can see I have a little glucose. Oh, it didn't pop up yet. Well, the green represents all of the fiber or roughage from the forage reaching the hindgut, which is very slowly fermented by fiber-loving bacteria, producing those volatile fatty acids. The metabolic response to all of this is that there's very little glucose or sugar coming in at once, and then in turn, insulin stays fairly level, so you don't get a big peak in insulin this way. Everything stays pretty flat. Now on the flip side, if you have a horse that's turned out on a lush spring pasture like we're having here right now in Tennessee, or if you give a horse a large cereal-based meal at once, they get a large bolus of feed at once that contains a lot of sugar and starch and fructan, and we'll talk about those in a little bit. But the principle here is that they get to the stomach and they exceed the capacity of the small intestine. So there's just too much feed and too much sugar and starch within that meal for the enzymes in the small intestine to break it down efficiently. So all of those sugars and starch and any fructan that was in the grass is going to pass on through to the hindgut, which is then rapidly fermented. So it's a bit hard to explain without seeing people's faces, but the idea here is that sugars and starch are rapidly fermented along with fructan. In result to these large meals at once, you get a big peak in glucose because you're getting a lot of those simple sugars or starch at once, which is broken down into glucose in the small intestine. In turn, you get a big peak in insulin or high levels of insulin being released from the horse's pancreas in response to that large glucose. And then in turn, these types of disorders are associated with laminitis. So tying those pictures together and where that ties into laminitis, you have what we call gram-positive lactate-producing bacteria breaking down all those sugars, because lactic acid-producing bacteria really like starch and sugar. In return, lactic acid decreases the hindgut pH. When that happens, that kills off the good bacteria that like to break down the forage. So then you get endotoxins within the hindgut. So not only is that a problem within the hindgut, but there have been studies where they gave high doses of starch. And on the left you'll see a horse's normal intestinal wall, and on the right is a horse that has laminitis, which was induced by those high doses of starch. So with that decreased pH, it causes an acidic environment, which actually deteriorates the intestinal lining, making the intestine permeable, allowing those endotoxins to be released into the bloodstream. So really there's two parts here. There's the insulin-resistant side of laminitis, and then there's the theory of intestinal disturbance causing laminitis. And we really don't know a lot of details that tie together the pathway to the hoof, but this is where research has gotten us so far. So what are the risk factors for laminitis? And again, these are conditions that would increase the risk for your horse of developing this disease. So in horses, or the animal, our main risk factors for this nutritional-linked laminitis are obesity, insulin resistance, and metabolic syndrome. Oopsie. Sorry, guys. In the diet, the main risk factor is non-structural carbohydrates. And non-structural carbohydrates are going to vary in pasture according to environmental conditions and growing conditions. In hay, it's going to be determined by the conditions under which the hay was harvested. And if you're feeding your horse commercial feeds, well, it's going to depend on the ingredients of that particular feed. So what about obesity? Obesity is a huge issue in horses, and it's defined by a body condition score of about an 8 to 9. Even upper 7s over prolonged periods can become a bit of a risk. And the problem here is too many calories and not enough exercise. We have a lot of horses out there that are, our backyard ornament, or a show horse that we're overfeeding and underworking. So that's the main cause. We also get thrifty genotypes or phenotypes, and that would be a horse that's genetically predisposed because of their evolutionary patterns, like a pony, for example, a Welsh pony evolving in Wales, where they had seasonal availability of nutrients, where in the winter it would be less and then in the summer it was more, so they go through seasonal shifts and weight changes. Well, now we're feeding these horses very lush pastures developed for dairy cattle originally, so they just flourish and get way too fat. It just provides way too many calories for them. Some other horses that are prone to obesity and laminitis are Morgans and Arabians and warm bloods in particular. So again, a problem is that we no longer have a seasonal shift in energy balance, where horses in the wild might lose weight over the winter and then gain weight in the summer. With the way we manage our horses, we're keeping them at that upper body condition, year-round. It's often encouraged in the show ring too, and I made that point because this picture here that I have on this slide, this horse is borderline obese, and this is a top show hunter, and that's the way, unfortunately, we like our show hunters to look. We like them big and round, and that warm blood body type is looked upon highly in the show ring, but then we don't realize that we could be causing some underlying issues. Obesity can also be defined as regional adiposity, where it's associated with horses prone to laminitis. And here's a horse that's showing really true signs of regional adiposity. You can see the crusty neck and fat rolls along its side, and then fat deposition again in its tail head. So if you have a horse like this is where we're really concerned about a predisposition to laminitis. So what about insulin? And there's been a lot of talk about insulin and insulin resistance. So I thought that it might be worthwhile just kind of talking about what insulin is. And it's a hormone that's used for regulatory purposes in metabolism, vascular function. It has a role in inflammation, tissue remodeling, and growth. Here, what we're really concerned about is when it's secreted by the pancreas to promote glucose uptake by the horse's tissues. So when we have insulin resistance, we have failure of that response to insulin, so that horses are not properly taking up glucose by their tissues, caused by a decreased insulin sensitivity. This can then affect the horse's hoof lamina because they're not being able to take glucose up by those tissues, which is a nutrient that those tissues need to survive. So insulin resistance association with laminitis comes from high sugar starch diets in either forages or feeds. So then you get an increase in blood glucose. That insulin is secreted in response to the blood glucose increase. And then you get insulin resistance because of those continuously high blood insulin levels, or glucose levels, that then results in high insulin. So here we have a mistake. This should say insulin equals vasodilator. And the problem is that when you have tissue that isn't sensitive anymore to insulin's effects, we're promoting a constant vasoconstriction. So with decreased blood flow, we're getting decreased amounts of glucose being transported to the hoof. So we're compromising blood supply to the hoof, thus decreasing nutrients such as glucose. So equine metabolic syndrome ties all of these together. It's characterized by obesity and insulin resistance and laminitis. So horses that do have equine metabolic syndrome, or if you think your horse has equine metabolic syndrome, should be screened or evaluated to determine if it actually has this problem. And you can take a basal insulin value, and right now there's just starting to kind of get into this realm of research, but we're thinking that anything less than about 20 micro-IUs per ml would be a horse that's insulin resistant, and then combined with this body type and laminitis, you could have a problem. Okay, so those are the horse factors. What about the dietary risk factors? And here we're looking at dietary risk factors in pasture, hay, and feed ingredients. So non-structural carbohydrates are our main risk factor here. We have starches, sugars, and fructan. And these are the three primary components that make up non-structural carbohydrates. And these are found in the plants, which I think, here we go. So you have plant carbohydrates and you have the cell contents, and these are the carbohydrates that are found in the plant cells. And then on the right you have the cell wall. So the carbohydrates that are found in the cell wall are the fibers, and those are what are slowly fermented in the hindgut to keep a healthy digestive system going. So within our cell contents we have sucrose, fructose, starch, and glucose. These are all sugars and polysaccharides that are hydrolyzed in the small intestine, and that just means they're broken down with the addition of water. So these sugars and starch are broken down in the small intestine and typically absorbed into the blood supply, and the horse uses them for energy. Oops. And then all of those combined with fructan, if they reach the hindgut, are rapidly fermented, and that's what's represented by this red arrow here. So if any of those sugar, starch, or fructan reach the hindgut, they're rapidly fermenting, causing that decrease in pH and compromised large intestine. We have the fibers over here that are broken down slowly in the hindgut, releasing the volatile fatty acids from bacterial fermentation. Okay, so where are these different types of non-structural carbohydrates found? Starches primarily exist in legumes such as clover, but primarily we're worried about starches in cereal grains. And this doesn't necessarily mean that it has to be a sweet feed, because again it's coming from the ingredients being the grain or the cereal grain. So you can have a pelleted feed that's just as high in starch as a typical sweet feed. I always like to make that point because people always think that pellets are lower in starch, and that's not necessarily true because pellets are made of the same ingredients, they're just ground up and processed differently. Okay, so sugars and fructan are primarily found in cool season grasses, and that would be tall fescue, orchard grass, perennial ryegrass, Kentucky bluegrass, for example. And I put this on here not to confuse you all, but just to show you that non-structural carbohydrate analysis can be very confusing. So you have starch. These are some of the primary terms that are associated with non-structural carbohydrates. So starch is broken down enzymatically into glucose. Then we have what's called ethanol-soluble carbohydrates, or ESC, and these are the simple sugars, glucose, fructose, and sucrose. We also have water-soluble carbohydrates, which include those simple sugars plus fructan, because fructan is water soluble. It's just not able to be hydrolyzed in the horse's small intestine. So NSC means starch plus all the simple sugars plus fructan, so starch plus WSC. Currently, there's not an analysis available for fructan, so that's something we're working on. One thing I would caution is that different laboratories do use different do have different meanings. So make sure that when you do have your forages or pasture tested or feeds tested, that you understand what your laboratory is analyzing and how they're measuring it in order to interpret those results. Okay, so we're going to get into a little bit of research that I did at Virginia Tech at the Mayer Center, and actually our person answering questions, Dr. Tanya Cubitt, was there for this study and helped a lot with it, so she has a very good understanding of what went on here. So what we did is we had 10 horses that were on pasture, and then we had 4 in stalls, and we wanted to look at circadian or diurnal variation and those non-structural carbohydrate fractions in the forages, and then how that in turn affected the horse's metabolism and digestive profile. So every hour for 36 hours or 42 hours total, we took pasture samples and then concurrent blood samples from the horses so we could evaluate these different patterns. Then we had the 4 horses in the stalls, which is the picture on the right, to compare their metabolism and digestive processes to the horses that were grazing pasture. So this is a lot of numbers, and I know you're all probably going, yikes, but this is the main thing we want to look at here. And this was analyzed by Equine Analytical, where NSC equaled sugar and starch and fructan, so this was everything together. So again, the study was done, and you can see on the top, April, May, August, October, and January, and then to the far right was the value of the hay. So the main thing to see here is that the total amount of non-structural carbohydrates was a lot higher. It was twice as high in April as it was in the other months. The percent of sugar, which was simple sugars plus fructan, made up the majority of that NSC component at 18.9 or 19 or so percent dry matter. And the starch was relatively low and stayed pretty consistent across all of those months. Okay. So this is looking at the circadian or diurnal variation in the non-structural carbohydrates of the pasture throughout the different months. So the first one we have here is April. So you can see we started at about 6 in the morning and went about 36 hours out from there. So we started at 6 p.m. the first day and ended at 6 p.m. the second day. And one pattern you notice immediately is that it's lower very early in the morning and then increases throughout the day and peaks pretty late at night, kind of in the early evening hours, goes back down again throughout the overnight hours, as lowest in the morning, and then increases again throughout the day, being highest in the early evening. So we definitely noticed that there was a circadian or diurnal pattern. However, the overall average amount of non-structural carbohydrates was around 20% dry matter, which is relatively high, especially if you compare that that average or mean to what it was in May, which was down there around 11. So we still saw a bit of a diurnal variation or fluctuation, with it being lower in the morning and higher in the evening. However, the overall level was a lot lower. And these are figures just looking at August, October, and January. So August, again, you see a bit of a curve there, the line representing kind of a diurnal fluctuation. However, in October and January, we had a pretty flat line. There wasn't any variation. And an interesting point here is that in October, we expected to see an outcome that was more similar to April, because this was a tall, fescue, cool season pasture. So that being a cool season, usually in the fall they go through that regrowth period, and those environmental conditions in the fall usually lead to higher NSC and similar patterns to what we saw in April. But if you notice up in the top right in those photographs, it was very cloudy. Oopsie. What happened? Sorry, guys. In the photographs up in the top right corner, in both October and January, it was very cloudy and rainy and overcast, that leading us to believe that those immediate environmental conditions really do dictate the non-structural carbohydrate content of the pasture. Okay, so we took this a step further because we wanted to know what the culprit was. There was a lot of talk about fructan being the main culprit because of its rapid fermentation within the hind gut. So these results are from a different laboratory procedure where we were actually able to break down the different components of non-structural carbohydrates into the sugar, fructan, and starch components. And so the top line is the total amount of NSC, the line below that is the amount of sugar, the yellow line is the fructan, and the blue line is the starch. And what you can see is that the sugar makes up the primary component of the NSC and really flows along with that same diurnal pattern as the total non-structural carbohydrate. So it's really the sugar here that's a concern in my mind, and not necessarily the fructan or starch in this particular pasture. And just for fun, we'll look at some of these other months. This is May, so again that diurnal variation with sugar making up the majority of the fraction. And then in August, again, we're primarily seeing sugars here, as seen by those red lines. And then in January, you can see a similar pattern. Okay. So then what we wanted to know was what was causing the fluctuation in non-structural carbohydrates. So we measured lots of different environmental conditions, both with a weather station and the microenvironment or microclimate with different instruments. So for this talk, I'm only going to talk about a couple of the biggies. So this first one here is temperature. So each one of these represents the different months, so April, May, August, October, and January. And the blue line was the change in temperature throughout the 36-hour period. And the green line was the change in non-structural carbohydrates throughout that 36-hour period. And really in all months, you can see the relationship with temperature and the non-structural carbohydrates, where it follows that same pattern. So there was in fact a relationship with the external temperature. Okay, so this is radiation, which just means sunlight. So the green bar here is the non-structural carbohydrates, and the yellow line, sorry, they're kind of hard to differentiate, but the yellow line is the intensity of the sunlight. And we know that sunlight promotes photosynthesis, which then in turn creates sugars within those plants. So we expected to see this, and we did, where there was a relationship between the intensity of sunlight with the total amount of non-structural carbohydrate in the tall fescue pasture. And I thought this was really interesting. This is relative humidity. So again, the green line being the non-structural carbohydrate pattern, and the red line representing the relative humidity. So here we had an opposite effect, so that as humidity went up, non-structural carbohydrate content went down. And you can actually see over here in October and in January, when it rained, the non-structural carbohydrate level really decreased. So we did find that the environment was the main factor that it influenced the pasture non-structural carbohydrate concentration in this particular pasture. We determined that most of the non-structural carbohydrate was comprised of simple sugars, such as glucose and sucrose and fructose, and there was little variation in starch and fructan, which were both relatively low as far as percent dry matter. We did see a diurnal variation in April, May, and August, but really in April was when we saw those really high levels, and the NSC, again, related to the environment. So that's great, but then how does that affect horses that are grazing those pastures? So this is where we went in and examined horses in those same 36-hour periods during day and night, and that's what this picture represents. I thought this was kind of cool. This is one of the mares that we used in this study. This was probably about 3 in the morning, and you can see the little glow stick on her halter, and we used those because it was really hard to find the horses at night because they always wanted to go way back in the backside of the pasture, and we didn't want to get a lot of flashlights out because we know any stress to the animal would influence our metabolic profile. So we really wanted as little stress as possible, and Dr. Cubitt's fiance was actually the inventor of using these glow sticks to find the horses late at night. Okay, so here we have more data, which I'm sure is a little boring, but I think it's really interesting. So the green here we have, this is the amount of insulin in the horse's blood throughout the 36-hour period. We started the horses at 9:30 in the morning and ended 9:30 at night. So the green is the insulin levels in the grazing horses, and the blue are the insulin concentrations in the horses that were in the stalls fed hay only. All right, so you see a similar pattern to what we saw with the non-structural carbohydrate level in the pasture. The main thing to note here is that in April, the overall insulin concentrations were very high. And these are averages. We had some horses that were over 200 micro-IUs per ml, which we thought there was something wrong with the analysis, and it just turned out that we had a couple horses that turned out to be insulin resistant. But the main thing here is that in the grazing horses, we saw insulin concentrations that were similar to what you see in horses fed high-starch cereal grains. And these horses were just on pasture with no other feed. So then we go on to May, and there's really no difference in the insulin or blood insulin between grazing horses and those horses that were on pasture. These are just the same August, October, and January. There were no differences in horses, whether they were on pasture or on hay. So this kind of looks confusing, but it really ties it all together. The green sine wave is the non-structural carbohydrate in the grass, and the red is the insulin levels in those grazing horses. So you can really see a pattern that as the NSC went up and down, the insulin in the grazing horses went up and down. Down at the bottom you have the hay insulin and then the hay value for non-structural carbohydrates. So like I said in the beginning, not only is insulin and insulin resistance a risk factor or a theory behind laminitis, but we're also worried about intestinal disturbances within the hind gut. So we went in and looked at not only blood but also fecal lactate levels to suggest rapid fermentation of sugars, and we did find in fact that fecal lactate was higher in horses on pasture than horses fed hay, with the red bar being horses on pasture and the yellow bar being pasture, horses that were fed hay only. And these two bars are just two types of lactic acid, the one on the left being L-lactic acid and the one on the right being D-lactic acid. And typically what we're concerned with is D-lactic acid because that denotes rapid fermentation. We also found that the fecal pH was slightly lower in the horses that were on pasture. And by looking at the two bars between the grazing and the control hay diet, they don't look that different. But the grazing horses, the pH of their manure was about 6.9, and in the control horses it was about 7.4. So there was a difference there between pH. So we knew there was something going on within that hind gut in response to those high sugar and starch levels in the pasture. And those figures, I should have mentioned, were just from that April study. We didn't find any differences in the other months. So our conclusion here is that there are variations in insulin in grazing horses that are associated with the non-structural carbohydrate content of the pasture, and these being a response to rapid fermentation in the hind gut of those simple sugars. So the main thing we need to do here is define grazing management strategies to avoid those risk factors in horses and in the forages. So the implications of this research are that we know that insulin resistance and rapid fermentation in the hind gut are risk factors and may exacerbate any conditions leading to laminitis. And we want to avoid pasture laminitis through grazing at different times of the year under different conditions. However, we do need to do a lot more research in different parts of the world using different forage species. This was just one pasture and one area of Virginia, and it really depends on the area that you're in, the species of grass, different breeds of horses. So we're really just starting to cut this open. One point that I really wanted to make throughout this, and I don't know if I've done a very good job at it so far, I don't think I have, is that not all horses are at risk for laminitis. And you have to look at the genetic predisposition, whether that horse has that thrifty genotype or it's that easy keeper that just seems to get fat on air. And we need to look at our environmental conditions when our horse might be on risk, the feeding management that we use for our horse. And in that, so if you do have a horse that has been determined is at risk either by a screening test defining that it's insulin resistance, or it's got equine metabolic syndrome, or it's had laminitis before, then we want to go ahead and look at the hay and the feed to reduce our risk. So we looked at my data, and this data just looks at averages of samples that were collected throughout the country. So you have grass hay, mixed mostly grass hay, legume hay, mixed mostly legume hay, and grass pasture, and mixed mostly grass pasture. The first column is just the average amount of NSC in these different types of forages, and then the next column is the lower amount. This is just kind of a scale here, a lower amount and then a higher amount that has been reported, and this is based on about 2,500 samples from Equine Analytical's feed library. So really what you see here is you really need to test your hay or your pasture, because it can vary widely. You can be anywhere from 8 to 18 for a grass hay. And what makes hay different are the conditions under which they were harvested or cut, and also the forage species. So if hay is cut in the morning, it's typically going to be lower in non-structural carbohydrates, and that's because forages respire and lose their sugars after they're cut until the moisture is about less than 40%. So here in the east, where it's real humid and where our hays have to sit out a really long time to cure, we typically find hays with lower sugar NSC levels than out west, where it's very arid and they dry very rapidly. So here we have, I always say, fast, dry, and sunny, it's high NSC, and slow, dry, and humid, a lower NSC. And of course, these are going to vary, and these are just basic guidelines. You can also soak the hay if you have a horse that you're worried about. You can either put it in a tub or wheelbarrow and soak it with water, because these are water-soluble carbohydrates, if we're thinking of simple sugars and fructan, either in 30 minutes in hot water or an hour in cold water, and then of course pour that water out. There's some information to indicate that you may lose other nutrients or minerals or vitamins, but this isn't widely published yet and still being examined. Alright, so what about feeds? And before I came to Tennessee, I worked for a feed company, and it's really funny because all the feed companies' goal is to get the feed with the lowest amount of NSC and the name that makes everybody feel safe or guarded against their NSC. And these are just some different examples of feed that I could find. And over on the far right are the NSC content of these different types of feed. And you see that there's really a range from anywhere from 11, or some companies now have, less than 10, up to 34. And really this doesn't mean a lot to me, because for most horses, they don't need a low NSC feed. Some horses really need that sugar and soluble carbohydrate for quick energy, like a racehorse. But if you do have a horse that's at risk for one of these diseases, you want to select something that's lower in NSC, or as low as possible. The thing to remember is that we don't have a cutoff level, and we don't know how much is low. So we like to recommend that something less than 10% NSC it would be safer for a horse that's at risk, less than 15 even, and anything above 20 we might be increasing our risk for that disease. But again, this is for horses that are truly at risk and have been defined to be at risk. And one thing that I find a lot is that people say, well, I'm just feeding my horse oats and he's not getting any sweet feed. Well, one thing to think about is that starch in those sweet feeds is coming from the cereal grain. So here we're not worried so much about those simple sugars, but we're worried about the starch, which is hydrolyzed into glucose and behaves the same way. So oats are about 44.4% dry matter, corn's about 70, and barley is 54. Now again, with any of these cereal grains or even the feeds we talked about on the previous slide, it depends on how much of it you're feeding. If you're feeding something that's, a 10% NSC, but you're feeding like 20 pounds of it a day versus 10 pounds a day, well then you're kind of defeating the purpose of feeding a low NSC feed. Where one of these, if you're just feeding a small amount, overall, the level is going to be lower in the total diet. Okay. And I put this in here just because I think a lot of people have a fear of the molasses and sweet feed. And I just wanted to talk about the purpose of molasses being in feeds is to inhibit mold growth or improve the palatability of the feed. And molasses is made up of about, typically, in commercial horse feeds, about 40% sugar. However, most feeds, and this isn't all of them because it can vary from 0 to 20% molasses, but a lot of feeds only have about 10% molasses. So a pound of feed is only going to have 4% sugar. So we're not really worried in commercial feeds so much about the molasses, but we're worried about the cereal grain component. Another thing to mention, that the beet pulp or molasses beet pulp, the amount of molasses in that is pretty negligible. Alright, so the whole point to this presentation, what we're really concerned with, is how to avoid this horrible disabling disease if you do have a horse that's at risk. And to me, the key point behind it is grazing management if you do have horses that are out on pasture. So these horses really need to have restricted grazing regimens. You need to avoid cold nights followed by sunny days particularly. It doesn't need to be a warm day, it just needs to be bright and sunny in order for these levels to NSC concentrations to be high. We know that early in the morning is safer than later in the afternoon because that's when our carbohydrate levels tend to be lower. We also know that a day that's overcast or rainy is going to be better than a bright sunny day, so it might be okay to leave your horse out a little bit longer on these overcast days. And along with that same theory, if you have a shaded pasture where there's a lot of trees and you're blocking some of that intense sunlight, you may also find lower risk there. You also need, we didn't talk about this a lot, but you need to avoid stressed forages. For example, in drought conditions, forages can really start to accumulate these non-structural carbohydrates for self-preservation, which then cannot be so good for your horse if it's at risk. And I really like to recommend dry lots if you do have a horse at risk or if you just want to avoid risk in the spring. And one thing to remember, though, is if you do have a horse on dry lot, they still need about 1.5% body weight a day in roughage, so you still need to supply some kind of hay to that horse, and make sure you test that hay to find out what your NSC content is. I like to recommend grazing muzzles. I think these are great. They really restrict the amount of forage a horse can get at once, and really restricts that grazing to the top of the leaves. And the best thing about this is that the horse isn't restricted in any way. They can be out on pasture and exercise, and I think that's where we really get into troubles, because we've got these horses where they're not able to exercise. So that's very important. In selecting hay for these horses, I like to recommend that if they are at risk, that it should be 10% NSC or less, and usually a mature hay is better than like a second cutting or third cutting hay. In feed selection, you want to select a nutrient-dense, low NSC feeds, and by nutrient-dense, I mean that their vitamin and mineral requirements are being met, but they're not getting too many calories. And that's just to really keep that weight management in mind. And there has been some work, if you do all of these things and you just can't get weight off your horse, there's been some work done at UT at the vet school where short-term high doses of Cyro-L or levothyroxine can actually reduce weight and increase insulin sensitivity. So that may be an option for you. Again, the main point here is exercise. These horses really need exercise. And one last thing I wanted to point out were some misperceptions. And that's that, I get a lot of questions, and I get a lot of feed catalogs and supplement catalogs, and there's a lot of metabolic supplements out there right now, and my concern is that we really don't have any research to validate the use of these different supplements, like magnesium and chromium or any other minerals that may tout improving insulin sensitivity or causing insulin resistance. So my word of caution would be to avoid these metabolic substances or supplements, because we really don't have any data out there to justify their use, and I think it's probably a waste of money. Okay, so the other misperception is that NSC is bad for all horses, and again, some horses really need that readily available source of energy provided by non-structural carbohydrates, particularly race horses or high-level event horses that aren't prone to this disease. We don't need to worry about NSC quite so much for them. And remember that low NSC feeds are for a small population of horses, but yet for that small population of horses, it's very, very critical that we do everything we can to limit the amount of NSC in their diet. So the main take-home message after all that is to determine if your horse is truly at risk before implementing the countermeasures, particularly when selecting commercial feeds and having hay tested and selecting hays, because I think people tend to freak out a little bit when maybe they don't need to. Most horses are not considered at risk. However, there are some that truly are predisposed, and we now know that we have screening tests available to determine if they are prone to laminitis, particularly if they have insulin resistance. So if we have a few individuals within a herd that may be susceptible, most often those are going to be those thrifty types, those ones that just do well on air and are real easy keepers, and where we have a problem with obesity. And if you do have one of those horses, dietary and weight management are really your only true keys to avoiding laminitis. So with that, I'd like to thank Dr. Tanya Cubitt, who's been answering questions on the chat, and everybody at Virginia Tech, where I did a lot of this research and worked together and to come up with some of these recommendations, and everybody at Michigan State, Gwen and Chris and Ashley at the Extension. Thank you all very much for inviting me to talk about this very important subject matter. Okay, so with that, I guess we can take any questions. I think we've got about 9 minutes. I guess if anybody has a question, you can just text it in your in the chat box. Tanya, do you have any points that you'd like to type in there? Tanya. Tanya might be answering other people's questions. Tanya's trying to answer all the questions. Okay. Well, this is very tricky. Tanya got a little behind. Well, I'm glad everybody had so many questions. I have to say this was very challenging, giving a talk, just sitting here by myself in my office. But I'm glad that my dog was quiet. Okay. Are there recommendations for changing... Oh, every time I try to read a question, it pops down. Are there recommendations for changing our pasture grass types? And this is a question by Hillary Horn. There is some link between grass species, and it's a bit new. The one we certainly know we want to avoid is perennial ryegrass. Our native species tend to be lower in non-structural carbohydrates. But it really, with a lot of the cool seasons, it's going to depend on the environmental conditions. Okay. Kentucky 31, or sorry, tall fescue and orchard grass, those can be fairly similar, and those are most common here. But typically native grasses tend to be lower in warm season grasses, because warm season grasses really don't accumulate any fructan and really tend to be low in starch as well. Trying to answer questions. Okay. Is the best type of hay grown from cutting a grass-timothy mix? Is the best type of hay grown for cutting a grass-timothy mix for Illinois? Not sure I understand that question. I think you're asking if Timothy mix hay is okay in Illinois. And again, one thing I want to stress is that the environmental conditions are going to be your main factor that contribute to your NSC content. So I just recommend testing. And if you can get a warm season grass, those do tend to be lower than your cool season grasses. And Timothy is a cool season grass, so technically it would be higher, but I don't think you can grow any warm season grasses in Illinois. Okay, is the friendly endophyte fescue higher in NSC? I don't think so. There's no data on that I know of. I will tell you what I know, and that's that the pasture that I researched, and I didn't get into all the details just because I didn't have time, is that I used the Max Q tall fescue in my research and found that it's pretty comparable to the Kentucky 31 fescues. Oops. Hey, Krishona's on there. Hi, Krishona. Oh, Krishona says you can grow warm season grasses in Illinois, but not the same pasture as the cool seasons. The cool seasons will outcompete the warm grasses. Thank you, Krishona. Bridgett, is the damage, I think this was about, is the damage to the cecum permanent? And I will tell you that in that study I showed, those horses were euthanized at the end of the study, so I don't know if they recovered, and I really don't know the answer to that. I would think that over time it would improve, but I think once damage is done, it's more susceptible to occur again because the cells have been compromised. So that's an answer to that question. All right, Elizabeth Lamb, what lab instrument is used to measure sugar or starch in hay? And there's lots of different techniques for measuring these. I prefer to use or recommend wet chemistry, where they take the sample and grind it and break it down and subject it to different either water or ethanol solution depending on the type of carbohydrate that you're wanting to look at. And there's also an NIRS technique, which is based on kind of average levels in other types of forages. So there's lots of different techniques, and it's not necessarily one type of instrument. But there's wet chemistry and NIRS are your two main types. Katie Watts is on here. Hi, Katie. I'm trying to find... All right, somebody asked Hillary, is laminitis more prevalent now than in past years, like 20 years? And laminitis dates back to, to hundreds of years ago or 100 years ago when we were working horses. So it does date back. I think one of the problems we see now is that we have a lot of horses that aren't being worked, and we also have horses that are living longer. So when they're living longer, I didn't talk about it, but for example, Cushing's disease has an association with insulin resistance, which may predispose to laminitis. So I think it's kind of multifactorial that we've got lots of different things going on. Tanya Cubit writes, Katie has been very helpful throughout. Thank you, Katie. I appreciate it. It's a bit tricky. I was getting distracted by everything coming up in the chat. I'm looking for more questions that haven't been answered.
Yeah, I'm just going to jump in for just a second. I think we've got time for maybe 1 or 2 questions, and then I think we'll kind of summarize.
Okay, thanks, Glenn. I think one question we have here is, when was the best time for cutting? The best time is to cut early in the morning, and you want it to cure longer because as it cures, it respires and will decrease those sugars. All right, someone wrote, if you interplant cool and warm season grasses, do you then have the same NSC risk throughout the season? And Hillary, what I recommend is, it's really difficult to plant these in the same stand, so I'd recommend having different paddocks, one paddock of cool season and another paddock of warm season, and put those horses on that warm season in the summer so you can have a bit more of an intensive grazing situation, because your cool seasons are going to be dormant throughout those summer months, and they outcompete the warm seasons. What percent moisture is recommended for drying hay when we know that less than 40 is what we really want to get to decrease the NSC?
Okay, I think we've had a lot of wonderful questions here, but I think we're getting to the end of our presentation. First of all, I'd like to thank our sponsor here for this evening. Heartland Veterinary Supply was our sponsor, and just once again I'd like to mention their website is www.heartlandvetsupply.com, and just want to make sure to thank them for sponsoring this webcast today. Of course, we'd also like to thank Dr. McIntosh for her presentation, and Dr. Cubit and everyone else for helping out with the questions. And most importantly, we'd like to thank all of you for your participation this evening. Our next webcast with My Horse University and E-Extension is going to be held on Tuesday, May 12th at 7 p.m. Eastern Time on the topic of feeding management in a time of rising feed prices. This is going to be presented by Dr. Mark Russell from Purdue University. And of course, for more information, visit our website at www.myhorseuniversity.com. I also would like to let you all know about a free webcast we're holding tomorrow, My Horse University along with the University of Minnesota. This webcast is by Dr. Molly McHugh, and the title of the webcast is Genetics 101, and which should be very informative and interesting webcast as well. So lastly, just remember that this webcast has been recorded and we will be uploading it to our My Horse University website by the end of the week. Feel free to send us any comments or suggestions for topics of future webcasts. Our email is right here at info@myhorseuniversity.com, and our phone number is listed there as well. So once again, just like to thank everyone for attending this evening, and I hope you all have a great night. Thank you, and thanks again, Tanya.
Thank you, Gwen. Thank you, Tanya, and everybody.